You have seen how we can use the big O notation to describe the runtime complexity of our algorithms. In an ideal world, we want our algorithms to be super fast and scalable and take minimum amount of memory. But unfortunately, that hardly if ever happens. It's like asking for a Ferrari for $10. It just doesn't happen. Most of the time, we have to do a trade-off between saving time and saving space. There are times where we have more space, so we can use that to optimize an algorithm and make it faster and more scalable. But there are also times where we have limited space, like when we build an app for a small mobile device. In these situations, we have to optimize for the space because scalability is not a big factor. Only one user is going to use our application at that moment, not a million users. So we need a way to talk about how much space an algorithm requires. And that's where we use the big O notation again. Let's look at a few examples. Here we have this greet method that takes an array of strings and prints a hi message for every name in this array. Now in this method, we're declaring a loop variable, and this is independent of the size of the input. So whether our input array has 10 or 1 million items, this method will only allocate some additional memory for this loop variable. So it takes O of 1 space. Now, what if we declare a string array like this? We call it copy and initialize it like this. So the length of this array is equal to the length of our input array. So if our input array has 1,000 items, this array will also have 1,000 items. What is the space complexity of this method? It's O of n. The more items we have in our input array, the more space our method is going to take. And this is in direct proportion to the size of our input array. That's why we have O of n here. And by the way, when we talk about space complexity, we only look at the additional space that we should allocate relative to the size of the input. We always have the input of size n, so we don't count it. We just analyze how much extra space we need to allocate for this algorithm. So that's all about space complexity. In this course, we'll only focus on runtime complexity because that's a bit more tricky. But from now on, think about the space complexity of your algorithms, especially in situations where you have limited space. See if there are ways to preserve the memory.